Science is a systematic, evidence-based approach to understanding the natural world and the universe at large. It is a way of thinking, a method of inquiry, and a body of accumulated knowledge that has evolved over centuries. At its core, science seeks to explain how and why things happen through careful observation, experimentation, analysis, and reasoning. It is rooted in curiosity and driven by the human desire to uncover the underlying principles that govern the physical, biological, and even social aspects of existence. Unlike belief systems based on tradition, intuition, or authority, science depends on empirical evidence data that can be observed, measured, and tested. The scientific method, a foundational framework for scientific inquiry, involves forming hypotheses, tentative explanations, conducting experiments, or making observations to test those hypotheses, analyzing the results, and drawing conclusions that either support or refute the original assumptions. Importantly, scientific conclusions are always provisional. They can be revised or overturned when new evidence emerges. This openness to revision is one of science's greatest strengths, allowing it to self-correct and evolve over time. Science does not claim absolute certainty. Instead, it offers the best explanations based on current evidence. It values skepticism, peer review, and reproducibility, which means that experiments must be repeatable by others under similar conditions to confirm their validity. Science is not a static collection of facts. Rather, it is a dynamic and ever-expanding pursuit of knowledge. The major branches of science are typically categorized into three broad domains: physical sciences, life sciences, and social sciences. The physical sciences deal with non-living systems and include disciplines like physics, chemistry, astronomy, and geology. Physics explores the fundamental forces and laws of nature, from the motion of planets to the behavior of subatomic particles. Chemistry investigates the composition, properties, and reactions of matter, playing a central role in everything from medicine to materials science. Astronomy studies celestial objects and the universe beyond Earth, while geology focuses on Earth's structure, processes, and history. The life sciences encompass biology and its subfields, which study living organisms and ecosystems. Biology examines the structure, function, growth, evolution, and distribution of life. Subdisciplines like genetics, microbiology, botany, zoology, and ecology delve into the complexities of DNA, cells, organisms, species interactions, and environmental dynamics. The social sciences, though sometimes debated in terms of their scientific nature, apply scientific principles to human behavior, society, and relationships. Fields like psychology, sociology, anthropology, political science, and economics use both qualitative and quantitative methods to understand patterns in human actions, cultural development, social structures, and decision-making. Science has not only transformed how we understand the universe but has also revolutionized every aspect of human life. In medicine, scientific discoveries have eradicated deadly diseases, developed life-saving vaccines, advanced surgical techniques, and improved diagnostics and treatments. In agriculture, science has led to innovations in crop production, pest control, and sustainable practices that help feed a growing global population. In technology, scientific understanding has driven the development of computers, smartphones, the internet, and artificial intelligence, reshaping communication, commerce, education, and entertainment. Engineering, closely tied to science, applies scientific principles to design and build structures, machines, and systems that improve the quality of life. Climate science and environmental science have brought awareness to human impact on the planet, prompting global efforts to address climate change, biodiversity loss, and pollution. Even in fields that seem distant from labs or formulas like ethics, philosophy, and the arts, science has had an influence, challenging long-held views about the human mind, free will, consciousness, and the origins of life and the cosmos. Science also has a profound philosophical dimension. Philosophers of science have long debated what distinguishes science from non-science or pseudoscience. One major criterion is falsifiability, as proposed by philosopher Karl Popper. For a theory to be scientific, it must be testable and capable of being proven false. This stands in contrast to beliefs that cannot be empirically examined or disproven. Another key concept is Occam's razor, the idea that the simplest explanation that accounts for all the evidence is often the best one. Science is also intertwined with questions of epistemology, the study of knowledge itself. How do we know what we know? Can we trust our senses? What role do assumptions, models, and paradigms play in shaping scientific understanding? Thomas Kuhn, in his influential work, The Structure of Scientific Revolutions, argued that science does not always progress linearly, but rather through paradigm shifts, periods of upheaval in which the dominant framework is replaced by a new one, such as the transition from Newtonian physics to Einsteinian relativity. These shifts demonstrate that science is not just about accumulating facts, but also about reinterpreting reality in fundamentally new ways. Importantly, science is a human endeavor and, like all human activities, is influenced by culture, society, economics, and politics. Scientific research requires funding, which often comes from governments, private industry, or non-profit institutions. And this can shape what questions are asked and how results are interpreted or applied. Ethical considerations are also vital in science, especially in areas like genetic engineering, artificial intelligence, medical testing, and environmental impact. Scientists must navigate the tension between what can be done and what should be done, balancing innovation with responsibility. The history of science is filled with both triumphs and failures, from the eradication of smallpox to the misuse of science in eugenics and weapons development. Therefore, scientific literacy among the general public is crucial. It enables people to make informed decisions, understand risks, critically evaluate information, and participate meaningfully in democratic processes that shape science, policy, and funding. In a world increasingly saturated with information and misinformation, understanding how science works helps individuals discern credible evidence from speculation or falsehood. Science also fosters a profound sense of wonder. It allows us to gaze into the farthest reaches of the universe, trace the origins of life, decode the language of genes, and peer into the intricacies of the human brain. It reveals a universe that is both elegant and complex, governed by laws that are consistent and comprehensible. Scientists often describe moments of discovery as deeply emotional experiences. Seeing a new star through a telescope, identifying a previously unknown species, or realizing a hypothesis has been confirmed. These moments illustrate that science is not dry or detached, but deeply human, driven by imagination, perseverance, and passion. The poetic beauty of the scientific worldview lies in its unity. From the smallest particles to the largest galaxies, from the single cell to the biosphere, everything is interconnected. Scientific understanding brings with it a sense of scale and perspective, reminding us of our place in the cosmos while empowering us to shape our future. In education, science develops critical thinking, problem solving, and an appreciation for evidence-based reasoning. It encourages curiosity, resilience, and open-mindedness, qualities essential not only for future scientists, but for active and thoughtful citizens. Science education must go beyond memorizing facts. It should cultivate a mindset of inquiry, skepticism, and ethical awareness. It should also be inclusive, recognizing that science thrives through diversity of thought, background, and experience. By engaging young minds and fostering a culture of scientific thinking, society ensures the continued progress and relevance of science. Looking ahead, science will continue to be central in addressing the grand challenges of our time. Pandemics, climate change, energy sustainability, space exploration, and the ethical implications of new technology. Interdisciplinary collaboration, global cooperation, and equitable access to scientific benefits will be essential. In sum, science is one of humanity's most powerful tools for understanding and shaping the world. It is both a method and a worldview, grounded in observation, shaped by logic, and open to change. It reflects our deepest aspirations to explore, to know, to innovate, and to thrive.